Oxygen-acetylene welding, more commonly referred to as gas welding, is the process of joining metals by heating them to the melting point and allowing the molten portions to fuse or flow together. When oxygen is combined with acetylene gas, the heat becomes intense, approximately 6,300 degrees Fahrenheit. Before attempting to weld, it is necessary to have a thorough understanding of the equipment, safety precautions, and the manufacturer's recommendations. Obtain permission from your instructor before using the welding equipment. Both cylinders should always be fastened securely as a protection against falling or rolling. Be sure there is ample ventilation in the room. The protective caps are always in place when transporting loose cylinders. Before attaching the regulators, open each cylinder valve to blow out any dust or moisture. Fasten the regulators to their respective cylinders. Note the right-hand threads on this oxygen connection. All acetylene connections have left-hand threads. This safety measure prevents accidental interchanging of the two different components. Inspect the hoses before using. The green hose is screwed onto the outlet side of the oxygen regulator. Note the right-hand threads. The red hose is always attached to the fuel gas, in this case acetylene. Again, left-hand threads are used. The opposite ends of the hose are connected to the torch butt, whose primary function is to serve as a handle. The red hose for acetylene is secured with left-hand threads to the stem marked gas. The green oxygen hose is attached to the stem marked oxy. Avoid contacting the entire welding unit with oil or grease. With the presence of oxygen under pressure, oil or grease may ignite violently. This includes greasy gloves or oily hands. All connections thus far have been tightened with a wrench. Choose a welding tip of appropriate size and screw it onto the torch butt. Tighten it with your fingers only. Never use a wrench. It should be pointing in this relative position. Most regulators have two gauges. One gauge shows the high pressure in the cylinder, and the other shows the pressure delivered to the torch. The purpose of the regulators is to reduce high storage cylinder pressure and to maintain constant gas pressure at the torch. Before opening the main valve on the oxygen cylinder, make sure the pressure regulator screw has been backed out and that the torch butt needle valves are turned off, but not so firmly that they are difficult to open. Stand to one side and open the oxygen cylinder valve very slowly. When the high pressure reaches maximum reading, open the valve all the way. A full tank of oxygen contains about 2,200 pounds per square inch of pressure at 70 degrees Fahrenheit. As yet, no pressure is seen on the low pressure gauge. Turn the pressure regulator screw in clockwise and set the pressure to correspond with the size of the welding tip, in this case 4 pounds. If too much pressure is accidentally set, Merely backing out the pressure regulator screw alone will not reduce the pressure. The needle valve will have to be opened while adjustment is being made. To set the acetylene pressure, first back out the pressure regulator screw. Then open the cylinder valve slowly, only 1/4 to 1/2 turn. If a wrench is used, leave it in place so the cylinder may be shut off quickly in case of an emergency. A full tank of acetylene contains approximately 250 pounds of pressure. No low pressure is seen on this gauge until the regulator screw is turned in clockwise. Warning: acetylene line pressure must never be allowed to exceed 15 pounds. Acetylene gas becomes very unstable at pressures beyond this setting. To achieve an accurate setting of the working pressure, crack open the acetylene needle valve and then adjust for 4 pounds, the same working pressure as the oxygen. Before lighting the torch, select a pair of welding goggles with a shade number 5 darkened glass and place them on your head. Check the flint lighter for proper functioning. Never use an open flame to light the torch. Open the acetylene needle valve approximately 1/4 turn and light the torch immediately. If the flame leaps away from the tip, reduce the flow of gas at the torch needle valve. Now, increase the flow of acetylene until all traces of smoke disappear from the outer envelope of flame. Hold the torch butt firmly and take care to direct the torch away from other persons and equipment. No further adjusting of the acetylene needle valve is necessary. Now, lower your goggles and add oxygen by opening the oxy needle valve. As additional oxygen is added, the flame increases in heat. This setting is called a neutral flame, and its temperature is approximately 6,300 degrees Fahrenheit. 3 different types of flames can be adjusted for various uses. A carburizing flame has an excess of acetylene and is used for welding white metals such as aluminum and should not be used for welding steel. A neutral flame has an equal amount of oxygen and acetylene. It is used to weld steel and cast iron. It is important that one recognize the importance of correctly setting this neutral flame. Excess oxygen produces an oxidizing flame used in the brazing process. It is not used for welding steel. Turn off the flame by first closing the acetylene needle valve, then the oxygen needle valve. For beginning welding, select hot-rolled mild steel, 1/8 inch and less in thickness. Gloves may be used if desired. Light the torch and carefully adjust for a neutral flame. The flame should be aimed toward the end of the metal being welded. Hold the tip at an angle of approximately 45 degrees. Welding direction travels from right to left. This welding operation, called puddling, is the basis of all gas welding, melting the base metal at a constant rate. The beginning welder will have best success if he starts out by using a small circular motion. Notice the inner cone does not touch the metal. If this occurs, a gouging effect takes place on the metal surface. This undesirable foaming and boiling of molten steel is the result of welding with a carburizing flame. This will leave a brittle, porous, scaly weld zone. A cascade of sparks indicates an oxidizing flame. Too much oxygen. A weak and porous weld zone will result. A properly adjusted neutral flame produces a smooth, quiet pool with a small, floating, luminous particle moving around the lead edge. Periodically, it may become necessary to check and readjust the oxygen needle valve for a precise neutral flame. A split flame indicates a dirty or clogged tip. Also, a definite change in sound might be heard. If this occurs, clean the tip orifice with the appropriate size tip cleaner or drill. Be sure the oxygen needle valve is cracked open to prevent the dirt from entering the tip. Two pieces of metal may be welded together utilizing the basic fundamentals of puddling or fusion welding. First, tack weld the left end to prevent heat expansion of the joint. Then, starting at the right end, both edges are brought to melting temperature and fused or welded together. Only after puddling and fusion welding has been learned, a filler rod of like material may be added to the molten puddle to build up and strengthen the joint. Notice the filler rod is held extremely close to the flame to keep the end red hot and near melting temperature. Dipping the rod into the molten puddle is the correct way of adding filler rod. This incorrect method of simply melting the rod under the flame will never work. These completed welding exercises have attained smooth appearance, even width, and proper penetration. Puddling, fusion welding with no rod, and rod welding. When welding is completed, turn off the acetylene needle valve, then the oxygen needle valve. Close the acetylene cylinder valve. Open the acetylene needle valve to bleed the pressure from the line and gauges. When both gauges indicate 0, back out the regulator screw. Close the oxygen cylinder valve. And open the oxy needle valve to bleed the lines. And when both gauges indicate 0, back out the regulator screw. Then gently close both needle valves. Hang up the hose and torch to prevent damage. A great deal of practice will be needed to become proficient at oxyacetylene welding. Be sure to follow all safety rules. Avoid dangerous malfunctions such as backfires and flashbacks. Especially avoid the use of oil or grease on the welding equipment. When you have finished welding, be sure to quench your hot metal or write the word hot on it with chalk. If in doubt, never guess. Always check with your instructor.